Let's begin today's lesson by reviewing multiplying polynomials. We're going to multiply two linear binomials together, and we're going to use the distributive property to do so. The method that I'm going to use to format my work will be the FOIL method. So let's begin distributing the x across x plus 2. Multiplying the first term yields x squared. Multiplying the x times a positive 2 yields positive 2x. Multiplying the negative 4, the inner term, gives me a negative 4x, and the negative 4 times a positive 2 yields a negative 8. Now the final step in this process is to combine like terms. So the product of the two linear binomials is a quadratic trinomial, x squared minus 2x minus 8. This equation has been written in standard form, which is when you organize the terms in descending order by their degree, 2, 1, 0. Now today we're going to be working with solving polynomial equations. And generally you're going to see a polynomial equation written like this, x squared minus 2x minus 8, which is referred to as standard form. And it's standard form because one side equals 0, and the other side is written in order by degree 2, 1, 0. Now to begin today's lesson, begin this process, we're going to begin working with what's called a factored form equation. Now this is called factored form because it's composed of two factors. The first factor is x minus 4, and the second factor is x plus 2. Now these two equations are equivalent. And to make sure that we see that, let's backtrack. Here we see that x minus 4 times x plus 2 yielded the standard form x squared minus 2x minus 8. Well, that's the same as the two equations that we have pictured here. So once I solve the equation in factored form, then the solutions will also be true for the equation in standard form. So we're going to begin here in factored form. To do this, we need to review the zero product property. The zero product property says that when you have a multiplication problem and the product is 0, then one of the factors has to equal a 0, or both of the factors might equal a 0. Let's review this quickly. 3 times some number equals 0. Well, since the product is 0, we know this factor has to be a 0. It can't be any other number. Let's look at the second example. Some factor times 5 equals 0. Well, since the product is 0, then the first factor has to be 0. Let's look at our last example. Now in this example, we could have the first factor equal 0, or the second factor equal to 0, or they both could equal 0. But we can make some assumptions about this because of this product of 0. The first factor has to be 0, the second factor has to be 0, or they both could be 0. Now knowing this allows us to solve quadratic equations or polynomial equations in factored form. Now our goal, remember, anytime you see the word solve, is to isolate the variable. So to do this today, we're going to use the zero product property. And so we see that we have two factors. The first factor is x plus 4, and the second factor is x plus 7, and the product is 0, and that's important. So now we know that the first factor could be the one that equals 0. So let's see what x would be for that to be true. X plus 4 equals 0. Or the second factor could be the one that equals 0. So let's find out what x would need to be for that to happen. So x plus 7 equals 0. Now once I've set this up, I'm going to simply solve each equation for x. To do this, I simply need to isolate the variable. So I'm going to eliminate the constant to find the value of x for the first equation. So x is going to equal negative 4. Need to follow the same procedure to solve the red equation. So I'm going to subtract 7 from both sides, and x equals a negative 7. So I think these are my two solutions. Let's check to see if they make sense. Now in our original equation we have x plus 4 times x plus 7 equals 0. Now our first equation, the blue one, asks the question, if x plus 4 is the factor that equals 0, then x would need to be a negative 4. So let's plug that into the x position. Now negative 4 times 4 is 0, so the first factor goes to 0. And negative 4 plus 7 is a negative 3. So now we have 0 times negative 3. Well, what's the product of 0 times negative 3? It's 0. So it looks like we found our first solution, and that is negative 4. Now we need to check the other solution. So it's x plus 4 times x plus 7. And that product is going to be 0. And the x value that we're checking this time is the negative 7. Now this one should produce a 0 in the second factor. So we get a negative 3 in the first factor, and a 0 in the second. And the product of negative 3 and 0 is still 0. So with our polynomial equations, we're going to have more than one solution. In this case, we have two. X is either negative 4 or x is a negative 7. Both cases produce a product of 0. So therefore, both of the x's are solutions. Let's try another one. Now remember, our goal is to isolate the variable. And once again, we have a factored form equation. So we have two factors, x minus half times x plus 7. And the product is once again 0. So because the product is 0, we can now use the zero product property. So we ask the question, what would an x need to be for the first factor to be a 0? So we ask the question, x minus a half equals 0. Or the second factor could be the one that equals 0. So let's ask the question, what would x need to be for the second factor to equal 0? Now to answer that question, we simply need to solve the equations. So to do that, I'm going to isolate the variable in the first equation by adding a half to both sides. That gives me an x value of 1/2. We'll solve the second equation by eliminating the constant from both sides. Gives me an x value of negative 7. So let's check our work. I'm going to open the parentheses and plug in the x value of a half. We're going to be subtracting a half from that. And that factor should go to 0. We're going to subtract a half, and we're going to add a half to 7 in just a second. We're going to see if that product is going to be 0. Well, the first factor produces a 0, and the second factor produces a sum of 7.5. 7.5 times 0 is still 0, so our first x works as a solution. Now let's check our second x. Now the second x asks the question, what would x need to be for the second factor to be a 0? So we're hoping that second factor will drop to a 0 when I plug in the value of negative 7. Let's see what happens. So the first factor yields a result of negative 7.5. And that second factor, negative 7 plus 7, yields a sum of 0. Now our zero product property tells us that any number times 0 is 0, so negative 7 is also a solution to our factored form equation. So the factored form equation has two solutions, 1/2 and negative 7, or rather negative 7. Let's take a look at our last equation for today. Now this is a factored form equation, which means we have two factors in this case. 2x minus 6 is the first, and x plus 3 is the second. And once again, the product is 0. That's important. When the product is 0, we can then use that zero product property to solve the equation. So let's ask the question, what does x need to be for the first factor to go to 0? So 2x minus 6 equals 0. Or that second factor might be the 0 factor, in which case we need to figure out what x would need to be for that to work. So now that I have the two equations written, I'm just going to go ahead and solve those equations for x. I eliminate the constant from the left side. Leaves me with 2x equals 6. I'll isolate the variable by dividing by 2. That gives me the solution of x equals 3. The second one, I'm going to eliminate the constant, negative 3, from both sides. It gives me the solution of x equals negative 3. Now the final step will be to check the solution. So 2 times x minus 6 times x plus 3, we want that to equal 0. we substitute the first solution into the equation. And doing this produces a value of 0 in the first factor. 6 minus 6 is 0. The second factor produces a sum of 6. Once again, any number times 0 is 0, so our solution of 3 still makes the equation true. So this is our first solution. Now we need to check the second solution. Once again, that's going to be 2 times x. We're going to subtract 6 from that. We're going to multiply that times x plus 3. We want that product to be 0. Plugging in the x value of negative 3 into the x positions of the equation yields a negative 12 in the first factor's position and a 0 in the second factor's position. But you recall that any number times 0 is 0. So once again, we found our second solution, which is x equals negative 3. So our two solutions are either negative 3 or positive 3 in this equation. So let's review. We're going to be learning how to solve standard form equations. To do that, we're going to be starting with factored form equations. Because the two equations are equivalent, once we have the solution to the equations in factored form, we then have the solutions to the equation in standard form. Make sure you bring your notes to class tomorrow so we can discuss any questions that you have.